Hello.
Hi, I have to for a cross country meet, so I was just wondering for like this link that like I can just be on there.
Yeah, yeah.
And then okay. I was just making sure.
Sure. Yeah.
Okay, perfect.
Yes.
I'll be on there in like 5 minutes.
Sure. Hello.
Sorry for missing this couple days. I've been out of work. Do you mind if I just quick announcement before?
Yeah. Go ahead. Yeah. Deep talk. All right.
Hi, everybody. So our exam is going to be next Friday the 8th, as we've been reminded multiple times. So on Thursday, I will be holding like a pretty big review session. And I'm going to put another poll out like I did when SI session should be. It will be one question saying when works the review session on Thursday best for all of you. That'll take like 4 seconds to fill out. And I'll send it up tonight. Each other that'd be perfect, so we can get the most people there as possible. Thank you.
So I was talking about the solubility, right? So what kind of compounds are water soluble, and these are the ionic compounds. So as I told you from here, this is the periodic table, right? So I told you if these blue elements are combined with these orange elements, so they must conduct the electricity, right? And they conduct the electricity, that they are the electrolyte. They conduct the electricity only if they dissolve in water. So being this element is not enough. For example, if you already did the lab 4, you see in the lab 4 there was a iron oxide, that big test tube like that, and that is the red. You will see a lot of red thing here. So that is iron oxide, Fe2O3, and a conductive probe was put in here, and then it was connected with the computer here, and it shows a very small number, about 300 or 200 or something like that, right? By looking this periodic table, iron is here, oxygen is here. This must conduct the electricity, and if you do the experiment, it should give a large number for the conductivity value, right? Should be the electrolyte. But it is an electrolyte, but it does not dissolve in water. Make sense? If it will dissolve, it will give a big number. The light experiment would be successful. Conductivity value would be big. But this Fe combined with O does not dissolve in water. But even though this is the ionic compound, it is a non-electrolyte. Make sense? So like that. So some of the material here. So here, so what are non-electrolytes? Although look here, so there is a insoluble compound. So these are the ionic compounds. So compounds made up with the blue elements with the non-metal, right? So the orange element. If you look here, insoluble compounds, most of the salts of carbonates are insoluble. So meaning that, let's say you have a iron carbonate. So take any blue element like copper and carbonate. So this should be insoluble. Most of the carbonate are insoluble. Make sense? Look here, that's saying that if there is a CO3 there, that should be insoluble. How about the phosphate? Let's look. Let's pick one blue element from periodic table, that is Pb. So I pick one element there and PO4. So I put Pb and PO4. That's a lead phosphate. So if there is a phosphate, that should be the insoluble. And though this is an ionic compound, you put in the water, it doesn't dissolve, so it's a non-electrolyte. Make sense? Like that. And how about this one? That's oxalate. So let's say this calcium oxalate. So calcium oxalate, C2O4. So there is an oxalate. So this is a blue element metal. So this doesn't dissolve in water. So this is, although this is an ionic compound, this is insoluble in water. So it cannot behave as a electrolyte. Yeah. How about here? Same as a chromate. So chromate. So let's look up mercury chromate. HgCrO4. Mercury chromate. So this is blue element. So mercury chromate. So this also doesn't dissolve in water. That's what it is saying. Same as a sulfide. How about this one? Most metal hydroxide and oxides also don't dissolve. So for example, let's take iron. So iron oxide. So iron oxide, Fe2O3. So it should not dissolve. Most metal oxide don't dissolve. Make sense? Let's look another one. Copper oxide. So this is copper. This is oxygen. Copper oxide. Copper and oxygen sitting together. So this should not dissolve in water. Yeah. And then this is ionic compound made up of the blue element and orange element. It is not dissolving in water, so it is non-electrolyte. Yeah, so that's what it is saying. How about here? Exception, but all ammonium and the alkali metal cations and DAS are soluble. So these are soluble. So for example, take ammonium. So take that ammonium. So any this NH4 plus. So NH4 plus here, NH4 plus, and then combine with any of those. Let's say I'm combining that with a phosphate, PO4 there, PO4 there, right? So this guy has a -3, this guy has a +1. So this one goes here, this one goes here. So if I write the compound, that is NH4 3 PO4 like this. So this compound is dissolved, soluble in water. Make sense? So if you see ammonia, this guy sitting with this line, soluble. This guy sitting with this guy, 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 soluble. Other not soluble. Make sense? That's how we need that table. How about here? Let's go. And the alkali metal cation. So alkali metal means group 1. So look the periodic table and group 1. So I'm going to show the periodic table and we here. So these are the alkali metals here. LiNa, K, RbCs, Fr. These are called the alkali metals. Yeah. So these metals forming compound with this one, like LiCO3, soluble. So all those alkali metals are making compound with this are soluble, like that LiCO3, LiPO4, LiC2O4, LiCrO4, LiS. So all those group 1 elements sitting with them are soluble. Make sense? Or Na. So put Na with any of them that are soluble. Put potassium with K with any of them soluble. So that's what that's right here. And the BAS, so the barium sulfide is also soluble. So although most of the sulfide are insoluble, like if you take the calcium sulfide, it's soluble. If you take the calcium sulfide, it's insoluble. Look here. So it is saying most of the salt of this one are insoluble. So calcium sulfide is insoluble, but exception is if there is a barium instead of calcium, that is soluble. So barium sulfide is soluble. Make sense? So if you put the copper here, not soluble, like that. But if you put the sodium here, Na and S sitting together, and this is not the exact compound, so Na2S, so this is soluble. That's how we identify something is electrolyte or not, if it's ionic compound. Yeah. So let's go this way. Most of the metal hydroxide and oxide are insoluble, but there are some exceptions. Some are soluble here. Exception, soluble. Alkali metal hydroxide and BaOS2 and SrOS2 are soluble. Alkali metal hydroxide means all those group 1 elements. So here, lithium, sodium, potassium, francium. So all these oxide, Li2O, Na2O, P2O, Fr2O, all these are soluble. Yeah, group 1 oxide. Make sense? But FeO is not soluble. Fe2O3, CuO, this kind of thing are not soluble. These are not soluble. Only group 1 elements sitting with oxygen are soluble. Yeah? And hydroxide. How about the hydroxide? Same thing. So LiOH. So put those elements with OH. LiOH, then NaOH, and KOH, then FrOH. So these are all soluble because they are in the group with 1 element. Yeah. And how about that? So this BaOS2 also soluble, SrOS2 also soluble. So they are in the group 2. So BaOS2 is soluble. Soluble, SrOS2 is soluble. How about FeOS3? So let's write here FeOS3. So I have Fe and OS3. So something like this. It is soluble or not soluble? So it is saying that all those hydroxide are insoluble except this hydroxide. So this is insoluble. Make sense? Or CuOS2 or any other OS2. Yeah. So how about this guy? PbOS2. PbOS2. So here. So this Pb is not in this one. There is no Pb here. Yeah. All this Pb is all metal hydroxide are insoluble. Only these hydroxide are soluble. So this is also insoluble. That's how we did that here. Make sense? So like that. So but there is another easy table. So company make that table for their use, and I put it here. So it's much easier to read this one. You see here. So if you put fluorine with ammonium NH4F, right? So that's soluble. So go down here like the multiply table here. You go here. So NH4F soluble. It's giving everything, right? So easy to read. So let's go here, calcium. So this is a calcium. And then let's look with the sulfide here. Sulfur and calcium. So I go here. Slightly soluble. So slightly soluble means almost insoluble. Calcium sulfide is insoluble. That slightly soluble means insoluble. Like a multiply table, right? So let's look one compound here and see if it is a soluble or not soluble using this table. So you can use either table doing the homework. So I'm going to write the let's say lead oxalate. So lead oxalate. So I'm going to write the lead Pb and oxalate C2O4. So this is a compound, lead oxalate compound, right? Now I'm going to find the lead. Lead is, where is the lead? Lead is right here. And where is the oxalate? Right here. That's a it's not oxalate, it's an acetate. CS3CO2. So CS3CO2. So I'm going to write that one here. CS3CO2. So like that one. So is this this compound is soluble or not soluble in water? PV. I go all PV there, acetate here. So I go all the way here and I go all the way down here, right? So that right is soluble. Make sense? So lead acetate is soluble. So you can also use this table. Much easier, right? Just like the multiply. 2 multiply by 3, 6. Just like that. Let's look at another one here. This is a, what's that? That's a carbonate here. CO3 2 minus carbonate. So I'm going to do silver carbonate. So let's say silver carbonate. So I'm going to write the silver carbonate. So Ag CO3. So is it soluble or not soluble in water? Let's look. So Ag, where is Ag? Ag is there and carbonate is here. So I go there and Ag. So here. So this is Ag and here, right? Carbonate. Make sense? So it looks like the insoluble, right? You got it? So like that. So this is insoluble. Now let's write one more and then we'll move. So I'm going to write the AgNO3. AgNO3. Whether it is soluble or not soluble. Let's look at AgNO3. Where is Ag? Right here is the Ag. Where is NO3? NO3 is here. So I go like this here, and I reach here. So that's it. AgNO3. Clearly write is soluble. Green. Yeah. Is it? This is maybe this is much easier for you to practice. Now one more. Let's look at AgCl. So I put the homework like this in the third homework. AgCl. Let's look at AgCl. I have the Ag there, and I have Cl right here. So I go here, here, and here. So that's it's writing insoluble. Easy, right? Yeah. So this is a company, I think it's a free. So that company was making this, maybe they are using this kind of material in their company. So they make this out and put it there. So slightly soluble means insoluble in our case. Yeah. So when you do the really experiment in the real depth, so they just like a slightly soluble, it was a tiny bit soluble, something like that. But in our book, we just say either it's soluble or insoluble. Yeah. Slightly soluble here is insoluble. Yeah. Good. So this is much easier table. So I come in the first year here in 2020. So it was a little bit hard for them to look up the previous charts. So I put it here. So they found this. So now we are done with the solubility. Now we go with the types of chemical reaction here. So type of chemical reaction. So first one is the exchange reaction. So you put something in water. So let's say I put this is a water here, and so let's say here I have silver nitrate. Silver nitrate. So I have silver nitrate, very clear solution in water, and I have here let's say sodium chloride. So I have here sodium chloride. Sodium chloride. Two things. So I can dump both together here, or I can put in the new beaker. So both solution I put it here in water. And so what happens here? So like this. So when I put them, so what happens is AgNO3 react with NaCl like this. And what happens is this guy go to sit here, and this guy go to sit here. So they are extending their partner. Make sense? So this is called exchange reaction. So the front always sit in front, the back always sit in back. So you cannot put the back to the front or front to the back. Yeah. So look here. So Na is the front, so that will always be in the front. This is a blue element, right? Na is a blue element. So metal always sit first, and non-metal always sit second. And metal always sit first, non-metal energy always sit second. So they change the position. So Ag. So Ag is in the first. So this behind guy goes to sit there. So AgCl. And then so A is always first there, and then the behind element from there NO3 is going to go and sit behind. Make sense? So this kind of the reaction is called exchange. They exchange their partner. Yeah. So the most important thing here to know that the first element always sit the front element always sit front, behind element always sit behind. Make sense? Good. Metal always first, non-metal always second. So this is called exchange reaction. The anion. So what is anion? So this the front one is called cation because they have a E plus is a cation. So Ag is a metal, so that always has plus charge. And NO3 is a non-metal, so that always has negative charge like that. And then Na is always a blue element plus, so that's plus there. Cl is a orange element, so that is always negative there. So this guy go and sit behind, this guy go there. So they just change the partner. So A is plus here in the front, D go and sit here, B go and sit back there. You cannot write it BC. We always write the plus. Yeah, good. Here I already wrote this one. The reaction there I was writing. So Na with Na, NO3 comes sit here. With it's AZ, Cl goes there and sit there like that. Now our job here is actually is I write AQ here. So what happened here? NaNO3. So look the solubility chart. So all the nitrate, if you go back and look at NaNO3, whether NaNO3 is soluble or not soluble, you can go back here and look here. So Na is Na is here, NO3 is here. So I go here and here. This is the place of NaNO3, right? This is NaNO3 here. It's clearly say it's soluble, right? Soluble. So that's a AQ I write. Now let's look at another one. So you go back here. What's the another compound we found? AgCl. So let's go back and look what kind of compound AgCl is. So Ag is here, Cl is here. So I go like this and look here. AgCl. So right here, right? Ag and Cl, right? Here, insoluble, right? So that compound we call precipitate. So actually, I wrote there AQ, but it should be written as a precipitate. So insoluble meaning that's a precipitate. So there I write solid. Right? Yeah, not AQ, but solid. Make sense? If it is dissolved, we write AQ. If it doesn't dissolve, we write the precipitate, PPT or solid. Yeah, precipitate, PPT. Like that. So here we are doing some a chemical reaction in water. So look here, AgNO3, that's completely dissolved in water, so I write AQ. So if I throw the silver nitrate, that dissolved in water. KCl, completely dissolved in water. How about AgCl? We go back and look that table, and that doesn't dissolve, solid. And KNO3, so this change the position, KNO3. How about the KNO3? Let's look, is that AQ or solid? KNO3. So look here, K is here, NO3 is here. So I go like this and here, KNO3, right? Look here, it's a soluble, right? So KNO3 is AQ. Make sense? And AgCl will be, we already talked about that one. Ag is here, Cl is here. So I go like this, and from Ag, that's insoluble. Make sense? So it's important. So in the lab number 5, we will be all about this one. Is it soluble? It's not soluble. It's soluble. It's not soluble. Yeah. So let's go next one and look here. PbNO3 and K2CrO4. So this is completely soluble in water. AQ. This is also completely soluble in water. AQ. Now how about the PbCrO4 and KNO3? Let's look PbCrO4. PbCrO4. Pb is here. CrO4 is here. So I go all the way here and this one, PbCrO4, that is insoluble. Make sense? So PbCrO4 is a precipitate. So PbCrO4 is solid and KNO3. How about KNO3? Let's go look at KNO3. K is here, NO3 is here, so it is soluble here, the green here, right? So that's how we come up with this little subscript there. Make sense? So let's go look another here. The PbNO32 is completely dissolving in water. So this is AQ. This is completely dissolving in water. AQ. So they change the partner and PBS and ammonium nitrate we got. So how about the PBS? Is that solid or not? Let's go back and look at the PBS. PBS. This is PB. I have S here. So I go all the way here and look here. So PBS is clearly insoluble. Make sense? So PB and S. PBS is insoluble. Yeah, good. So we need to look like that. Let's look another one here. How about this one? And you can look the ammonium with the nitrate. So let's go back and look the ammonium nitrate. Here is a ammonium and here is a nitrate. So all so ammonium nitrate here is you see green here. So ammonium nitrate green, that's soluble. So soluble means aqueous. Yeah. So let's go look some other material here. So these they are just changing the partner here. OH go and sit with Fe, Cl go and sit with Na. So FeOH3 and NaCl. Let's go look at FeOH3. What happens? FeOH3. So Fe, do we have Fe? Yes, we have Fe here, and then do we have OH? We have OH here. So FeOH. Look here. So FeOH. So this compound here, FeOH is like FeOH is FeOH3 is insoluble. You got it? Important. Yeah. FeOH3. Now, how about another? We get NaCl. And now let's go back and look NaCl. It's a Na is here, Cl is here. So NaCl is here, so that's completely soluble in water. So we write Aq. Now let's practice one more. KGNO3 and K2CrO4. So K is going to sit with NO3 or NO3 is going to sit with K. CrO4 is going to sit with AZ here. So we got these things here. Az2CrO4. Let's go back and see Az2CrO4. What is that one? Az here and CrO4 here. Az. So CrO4 and go here and look here and Az here. So that is this one, insoluble, right? Az2CrO4 is insoluble. So insoluble. This is insoluble, so we write solid. Sometimes they write a precipitate, PP. And then let's go to look the KNO3. What is KNO3? So K is here, NO3 is here. So soluble. So you see, just by looking this table, you know everything. If you know how to use this table, so no need to study, this is soluble or not, and what happened. So it's very clear, right? So you just need to know how to do the periodic table and this kind of stuff, and you are perfect. Yeah? Good. Now let's go back here. So we just finished this one. What does AQ mean? It means these things are in water and it's completely soluble. AQ means they are dissolving. What does S mean? S means it doesn't dissolve. Any question? Yes, I give that table in the exam. Yeah, so you don't have to memorize it. So let's go here. Now let's go here and talk about spectator ion. So this is very important for lab number 5 also. Yeah. So whatever we do here, we do the same thing in the lab. So spectator ion. So there is two ways of writing the chemical reaction here. So let's write the same thing here. So I'm going to write the AgNO3. This is one compound and it is completely soluble in water, AQ, right? And then I am throwing the potassium chloride in that mixture. This is also completely soluble in water. So I write the AQ here. Now I exchange their partner here. So Az is sitting with the Cl in the reaction. So that is AgCl. And then K and NO3 sit together. So K first and NO3 second. First is first, second is second. Yeah. We cannot write NO3K. Yeah, that's all. Good. Like that. Now our job is we go back to that solubility table and look what is this one and what is this one. So I go back there in the solubility table and see how about that AgCl. Like Az is here, Cl is here. So I go here and look here. Look Az and across Cl. So that's insoluble, right? So I'm going to write that as solid. So that's a solid. So this is solid. So do the same thing for this KNO3 and that is AQ, completely soluble in water. Yeah. Now this is called a complete molecular what they call it's a kind of a complete molecular equation they call. Yeah, this kind of thing. Complete. We write everything there. Yeah. So complete molecular. Now what we do is we just take off this one. So this solid, I want to take off this solid from here. So solid, I take off from here, and that AZ is gone with the solid, and that Cl is gone with the solid, right? And here, see here, so AgCl is solid, so I just take out that one. So Az and Cl, I take out that one. So I'm left with what? NO3 here, NO3 minus, and then I have a plus here, and I already take that solid forming thing there, and then this I have A plus here and NO3 here. Make sense? So whatever solid is forming, I just take those out from my equation, right? And I write all that in here. So this is completely soluble. This is AQ. It's soluble in water. AQ is completely soluble in water. These ions are in water. AQ and AQ. So this kind of thing is called spectator ion. Those that don't form solid. Make sense? Yeah, they're just wandering around in the water. Yeah. Spectator. What does spectator mean? You just sit there and keep moving and keep looking. They don't make solid. They don't do anything. Yeah. So they are called spectator ion. Make sense? Easy? Good. So something that forms the solid. Take out those, and whatever is remaining, they are called spectator ions. Yeah. It's important for lab 5. And then that one, so whatever I just got that there, so I got AZ from there. I got AZ from there, so I'm going to write that. So AZ I got out from there, right? And then I put that there, and Cl I got out that from there, and I combine these two, and AgCl, and I write solid. So this ion is a AQ, so already dissolved, and it's already dissolved, and it's not dissolving, right? So this kind of the reaction, if you write something like this, that is called net ionic equation. Yeah. Net ionic equation means just take those ions which are forming the solid. Yeah. So that's called the net ionic equation. And those ions which are not forming the solid, they are spectator ion, and you write everything together. That's a molecular, full molecular form of the equation. Yeah. Everybody got that? So if you understand this one, lab 5 is all about this. So net ionic equation, just the solid forming. So this guy sitting with this guy, we are giving the solid. So we get this as a net ionic equation. So like we are done with this chapter. The next one. So I told you, so some definition are given here. So some definition. So complete equation or a molecular equation, meaning that you are writing everything there. So you're writing AgNO3 aqueous, NaCl is aqueous, completely soluble in water, completely soluble in water. You mix these two things in water, and you get AgCl solid, and NaNO3 completely soluble in water. So this, if you write this kind of equation, that is called complete equation or molecular equation. Yeah. Now let's go down and look another name. So full ionic equation. Now break each of those. So AgNO3. So break that Ag as an Ag plus, NO3 as AgNO3 as Ag plus, NO3 minus, and Na is plus, Cl is minus, and Az is combining with the Cl. AgCl, that's solid, and Na is plus, NO3 is minus. So this means NaNO3 is completely soluble in water. Na plus and NO3 minus. Yeah. So if you write something like this, that is called full ionic equation. So this equation is full ionic equation. Yeah. So I got everything and just write a plus and minus with each. Yeah. So front was plus, back was minus. Full ionic equation. Then we go to the next one. It is spectator ions. Ions in an ionic equation that do not take part in reaction. So Na this one, Na and NO3, Na and NO3, they give a compound NaNO3 and they are soluble, they didn't give solid. So those ions are called spectator ions. Yeah? So they don't take part in the reaction. So they are just wandering around in the solution. Yeah? And how about here? Net ionic equation. So remove NO3 and NaNO3 and Na from both sides, and whatever you are getting here, that is called net ionic equation. Basically, the ions that is giving the solid. So this is called net ionic equation. Yeah. So you are everybody got it? All right. So like that one. Let's practice some here. So there are some practice questions. So molecular. So CuNO3. So it's saying CuNO3 NaOH. Now they are reacting. So this OH is going to go and sit with the Cu, and NO3 going to sit with Na, right? So I show you here. So so CuNO3, CuNO3, 2. Aqueous means completely soluble in water. So this compound is completely soluble in water. Yeah. If you look at chart I showed previously, if the Cu below C, so Cu is here and Cu is here, NO3 is here, and go there and look that box here. That's a green there. So that means it's completely soluble in water. CuNO3. And where does this 2 coming from? From the head of this guy. So this guy has +2 charge here. That's how we write, right? And then there is a 1 here with a C. Where is this 1 coming from? From the head of this guy. So that this guy has -1 charge. So NO3 -1, a Cu +2. It works that way, right? So like that. Then we write that with the NaOH. So I'm going to write this compound with NaOH. So again, OH is one entity. So OH has 1 here. Na has 1 here. This 1 is coming from the head of this guy. So this is +1. And this one is coming from the head of this guy. So that's -1. So it's like this. You got it? So like that. Now let's exchange the plus and minus. So this behind guy is going to sit with the front guy. And this behind guy is going to sit with this front guy, right? Make sense? So I'm going to exchange this. That's a Cu is the front guy. And OH I have here. Now, how much charge Cu has here? +2, right? +2. So look here. So that's a +2. And then how much charge OH has? -1. So this guy has -1 here. So this 2 is going to go down. So this is 2 here. And this is going to go here. That's a 1. So we don't write 1 there. So CuOH2. Make sense? That's how it works. So if you know this part, you easily know how I write there. Where I just put 2 or I just put 1, right? So now let's look at another one, NaNO3. So that's a Na. So plus Na. That's Na and NO3. So you can again look there. Na has a +1 charge, +1 here. NO3 has -1 there. So -1 there. So Na comes here, 1 comes there, so 1, 1. So 1 we don't write. So that's NaNO3. Now you can go back and look this which are soluble and which are insoluble here. So go. I think so that was 3. That's 3, right? Which one at? So let's go and look at 3. I mean 4. So 3. 2, 3, right? Anyway, you go there and look CU and so look CU OH. So there is a OH there in that table. You will see the OH here, and then you will see CU somewhere here, and then plus like this, and you go like this and come like this here, and there is a box, and it clearly says right insoluble. Right? Yeah. So look at that. Make sense? So like that. Now this one that one. So I just know that this is solid, insoluble, solid, right? And then this one again, look the Na plus, and NO3, NO3 minus, and then go there, go down here, look the box here, that's green there, so that's soluble. Yeah. So this is AQ. But AQ means soluble in water. So you do something like this. Now this is a complete molecular equation, right? Complete molecular equation. Now spectator ion, which are spectator ion? You can easily say which is a soluble. So NaNO3 are spectator ion. That's a soluble, right? So from just by just looking here, Na plus. So the front one is +1, and then behind is minus. So these two are spectator ion because they didn't give the solid. Yeah. So what is the net ionic equation? Something that gives this one is the net ionic equation. So you write Cu 2 plus up there and OH minus 1 here, and you got this compound CuOH2, right? So CuOH2, Cu there, OH here. So this is the net ionic equation. Yeah. Anybody got that? Yeah, I think you need to practice a couple of times and so I just write down. So this one, another one is we're doing this one. So just look that one. And how about this one? We just finish this one, and let's go here. Which of the following does not between aqueous solution that conduct electricity? So the ionization of the molecule in water, dissolving a non-electrolyte such as sugar in water. So definitely sugar, if you dissolve sugar in water, it doesn't conduct electricity. We already did in lab 4, there was a glucose. Glucose is sugar, right? Sugar doesn't conduct electricity. Why? Because the sugar is made up of like this C6H12 O6, so all brown 11, brown, all brown 11 from the periodic table, so that doesn't give the ion, yeah? So that doesn't conduct the electricity. The ionization of the molecule in water, ionization breaks, and definitely if it breaks means that it conducts electricity. The dissociation of ionic compound in water, actually the number of this one, this sentence and this sentence saying the same thing, dissociation or ionization means same thing, yeah? Dissociation and ionization means same thing. So it's from the book, so I just put as it is here. All of these processes lead to the aqueous solution that conduct the electricity. So this does not conduct the electricity, so this is wrong. So this, although this sugar or water is dissolving in water, it does not conduct the electricity because all are made up of the C, H, and O. They are all non-metal, yeah? Non-metal elements. Make sense? So let's go down here. So, solubility. Which of the following is insoluble salt in water? Look there in that. What is that? Let me take this out. So that was a mix of. Yeah, finally open here. Let's go here. Yeah. So let's go here. So, which of the compounds are insoluble in water? Look, ammonium and nitrate here. Go there, and ammonium and nitrate. Ammonium NS4 is here, nitrate is here. So down ammonium plus nitrate. So this is soluble. Ammonium nitrate is soluble, right? Now let's look another. NaOH. Let's go there and look NaOH. Na is here, OH is here. So NaOH. Look here, this box is soluble, right? NaOH is soluble. It's much easier thing, right? And then let's go look another here, PbI2. Let's look down. PbI2. So Pb is here. Is there I is here. So PbI2. So I is here. So I and Pb, I go here. So the PbI2, I and SOS, insoluble. So that is doesn't dissolve, it's a solid. K2CO3, let's go and look the K2CO3. K is here, CO3 is here. So go here, K2CO3 is right there. So that's soluble. Easy? Easy. So now let's go another one and look here, LiCl. So let's go look at LiCl. So Li is here, Cl is here. So LiCl is soluble, right? So either you can use this one or you can use the previous type of chart, but I think this is much easier for practice. Yeah? Good. But if you know how to use both charts together, then you can easily form your own idea. So that one. So look here again. NiCO3, go there, and NiCO3. Ni is did you write Ni here? So probably they didn't write Ni, but if you go back in the another, but again by just looking the Fe, and if you go to the periodic table here, where are Ni? Ni is somewhere here, right? Ni, look here, Ni is somewhere here, and CO2. So Ni is just like Fe and Ni behave the similar way, because these are the D block elements, yeah. So they behave the same way. So if you really know about Fe, you can predict what happens with Ni, because they are behaving similar way with elements. So let's go there and look at Fe. So look here, Fe and CO3. So Fe is here and CO3 is here. CO3 is here. So maybe they don't have here, but I think FeCO3 is insoluble. I can go back here and look here, metal carbonate. So carbonate, look here, insoluble compound. Most of the compound containing carbonate are insoluble, right? So definitely that's insoluble. This carbonate here is insoluble. Yeah, so it's insoluble. Go to the calcium fluoride. If we have a calcium fluoride data here, calcium fluoride. So calcium, do I have calcium? Yes, I have calcium here. Fluoride, fluorine is here. So calcium fluoride, right? The first box here, calcium fluoride is insoluble, right? So let's go there, and then another one, NIS. Let's go in NI. Again, they don't have NIS, so I can go back a little bit up and look NIS. What happens to NIS? So sulfide. So look here, insoluble. So if there is a S, it's going to be insoluble. Make sense? Insoluble. So something salt containing S is insoluble here, right? So, and then how about the CuBr2? Let's go and look the CuBr2. There is CuBr2 in my easiest. This one CuBr2. Cu is here, Br is here. So look here, CuBr2. You can clearly see that this is soluble here, right? Soluble. CuBr2. So we do something like this. And then let's look at Fe3PO4. So Fe3PO4. If I have that one here, I'm going to look here. If this is a PO4 and Fe here. So Fe3PO4. So look here. F go down Fe and then PO4. It's insoluble, right? Fe3PO4 is insoluble. Or you can go back here and look what happens with the F. If you have the PO43, it's insoluble. Either you look here or you look there, it's the same. Make sense? So that's how we look this table. So I put those all salt from the book. So you can try this one yourself. Yeah, which set of soluble, which are not soluble. Just go back and look there and try to find those. So that is practice. So precipitation reaction. I already told you. So we are just what is precipitation? Precipitation means when one is a clear solution, another is a clear solution, you mix two together and you get a solid. That's called a precipitation reaction. Okay? So I already write that one here. So this reaction is a precipitation reaction. So this is a soluble, it is also soluble. I mix these two things together and I got this is a solid, this is a liquid. So this kind of the reaction is called precipitation reaction. Make sense? So this, when you see the solid here, oh, this reaction is a precipitation. Yeah. So, reaction. So there is another one also. So you can just change the position there and look the solubility chart. So this is PV. PV is going to sit with I. So PV has a plus two charge. If you see 2 here, that means PV 2 plus, right? So PV I2. That one compound is PbI2, another compound is K is a +1, and NO3 is +1, -1. So KNO3. So this dissolves in water. This does not dissolve in water. Look the dissolving table. It's PbI2 is clearly the solid. Yeah. So this kind of the reaction is the precipitation reaction. Everybody got it? Good. Very simple. If you know this trick, so you don't have to understand. Otherwise, we need to know everything, right? We need to memorize everything, right? So, but if you know how to use the solubility chart, it's much easier. Go here. Ba is a +2, Cl is a -1. So Ba and SO4 is a -2, Na is a +1. So this is a polyatomic ion there. So Ba sit with SO4, BaSO4, and Na and Cl sit together, NaCl. So look at solubility chart. This completely dissolve in water. This does not dissolve in water and give the white precipitate. Barium sulfate does not dissolve in water. Yeah. So just by looking at periodic the solubility chart, you know everything. Yeah. So again, we are showing the different type of the precipitation reaction here, mixing two solutions, making salt that does not dissolve, doing the same thing here. So yeah, just you can practice couple of same thing here. So anytime questions, so we'll practice couple of these in next class, and then we will whatever we talk today. Now, some time. This one.